This is the last lesson of Unit 3, where we basically take all of Unit 1 and redo it with complex numbers. So this is kind of the wrap-up to our big study of polynomial functions since the beginning of the year. After this unit, we move on to trigonometric functions, so we change gears completely and start looking at sine, cosine, and tangent from last year in geometry. So consider this polynomial. We end our last homework with where we really truly deal with polynomial functions. Consider the polynomial p of x, whose graph is shown. So we have this beautiful graph here of this polynomial. We don't need a factor to answer these questions. How many linear factors can I factor p into? Well, it's an x to the fifth polynomial, so it should have 5 linear factors. Should have 5 linear factors if we include complex numbers, because it is degree 5. How many real zeros does p have? Well, the real zeros are where I hit the x-axis. 1, 2, 3. P has 3 real zeros. You see the real zeros on the x-axis. We see our real zeros. How many complex zeros does it have? Well, if I have 5 factors, and 3 of those factors give me 3 real zeros, then I need 2 complex zeros. P has 2 complex zeros that I can't see. And complex zeros come in conjugate pairs. So, for example, I don't know if these are actually the real zeros. If you had 2 plus 3i, the other one has to be 2 minus 3i. Think of the quadratic formula and how the zeros differ only by the plus or minus there. So if I have 3 real zeros, I've got to have 2 complex, because I should have 5 in total, because I can have 5 factors, because it's a degree 5 polynomial. That's what the fundamental theorem of algebra is saying. If I have a degree 5 polynomial, I have to have 5 solutions if I include both real and complex numbers. Consider this ridiculous polynomial here. Find all the zeros of p. So let's tackle this. X squared plus 4. That can be factored as x plus 2i, x minus 2i, because that's the sum of perfect squares. When we factor the sum of perfect squares, we get complex solutions. X squared plus 1 is x plus I, x minus I, using that same idea that we did in the previous lesson. X cubed minus 8 is a perfect cube. So that factors as x minus 2 times, we'll square the first, opposite sign, their product, square the last, always positive. So if I want to find the zeros, I've got to set this equal to 0. And then use everyone's favorite property. If I multiply 1, 2, 3, 4, 5, 6, 7, 8 things together and get 0, one of these things had to have been 0. So I get x equals plus or minus 2i. Negative 2i and positive 2i. X equals plus or minus I. X equals positive 2. I'm going to come back to this quadratic factor because we're going to have some work to do here. That gives me x equals negative 3 halves, x equals 4 thirds. So I'm almost there, but I have to deal with this quadratic here. If you try to factor, you're going to end up asking yourself what multiplies to 4 that adds to 2. 1 and 4 don't work. 2 and 2 don't work, so we quit and use the quadratic formula and say x equals negative b plus or minus the square root of 2 squared minus 4ac all over 2 times 1, which is 2, so I'm not even going to write that. All right, let's deal with the discriminant. 4 minus 16. Type that into your calculator, please. That should not be the hard part of this. is negative 12 over 2. Well, let's deal with the square root of negative 12 over here. First of all, I need an I, a 4, and a 3. So 2i radical 3. Negative 2 plus or minus 2i radical 3 all over 2. So that gives me x equals negative 1 plus or minus the square root of 3i. Those are my other two solutions. So here are all my solutions to this disaster of a polynomial equation. It was already factored. I had to do a little bit more factoring over the complex numbers, factor some perfect cubes, and then use the quadratic formula. But these are all my solutions to this equation. If you plug any of these numbers in for x, one of these factors will become 0, which makes everyone else drop out and become 0 because 0 times anything gives me 0. Number 3, consider the polynomial p of x. Use the graph to find the real zeros. Well, the real zeros are found on the x-axis. Found it and found it. So I have x equals negative 1 and x equals 3. I've got two real zeros, which means I also need two complex, because overall I should have 4 total. I should have 4 total, so I have to have two complex zeros. So factor p by using the zeros from the graph. So I know I can factor p of x. I know it has a factor of x plus 1 and a factor of x minus 3. The question is what's the other factor? So if I know some of the factors and need to find the other one, I need to divide. So over here, I'm going to do some division. And unfortunately, I needed to do two separate divisions here. There's no way that box is going to be big enough. So I've got x to the 4th. Is that a minus or a plus? I drew over it too well. Minus 6x cubed, 11x squared. Warning, warning, warning. 0x and negative 18. So let's see what I get here. I've got an x cubed minus 7x cubed, negative 7x squared. That's good. I've got negative 7, I want to get back to 11. So I think that's 18 of them that I need up there. Minus 18. And that checks out. So now I took care of the x plus 1, but now I need to take this answer and divide out the x minus 3, because I don't need the x minus 3 stuck in there. So let's do another division of x minus 3. And I'm going to divide out x cubed negative 7x squared 18x minus 18. We get x squared negative 4x squared. And hopefully you can do this division on your own. We should be division masters at this point, where you can kind of just skip and say, yep, Coach and I got the same thing. We're good to go. Notice how both times I got remainders of 0, which makes sense because they're factors. X plus 1 and x minus 3 are factors. So p of x is x plus 1 times x minus 3 times x squared minus 4x plus 6. Now, we know we have complex zeros, so I'm not even going to try to factor that trinomial there. I'm going to jump right to using the quadratic formula. I'm going to jump right to using the quadratic formula and say x equals negative b plus or minus the square root of b squared minus 4ac all over 2 times 1. 16 minus 24 is the square root of negative 8 over 2. Well, that negative is freaking me out, so it's I radical 8, but 8 can get broken up into 2 radical 2. 4 plus or minus 2I radical 2 all over 2, which gives me 2 plus or minus the square root of 2 times I, once I use the commutative property there. So that helped me factor it, and I guess I did the next step. The next step said find all zeros. The find all zeros, well, I found them. -1, 3. And then my two complex zeros, which I knew I had, are 2 plus radical 2I, x equals 2 plus radical 2I, and x equals 2 minus radical 2I. So I skipped ahead there, but those are all my zeros.